Chapter P.3, Day 2 of Integer Exponents and Scientific Notation. Scientific notation, we are moving the decimal and writing this so that it has a number times 10 with an exponent. So if we're looking at this example where we need to write this number into scientific notation, we need to make sure that the decimal gets moved to right there, which means we are moving the decimal 1, 2, 3, 4 times. We will write 3.721 times 10 with some kind of an exponent of 4. Just don't know if this is going to be positive 4 or negative 4 until we think about this. This number right here is a very small number, a lot smaller than 3.721. Because of that, our exponent on the 10 needs to be a negative number. So our actual number was much smaller than our scientific notation value of 3.721. Okay, when we look at the second example, again, we need to have the decimal go after the 2. The decimal always goes after the first non-zero digit. So we have 2.85. We drop off all the rest of the zeros. Right now the decimal is over here after the number. We are moving the decimal 1, 2, 3, 4, 5, 6, 7 times. So times 10 to the 7. If that's positive or negative, we're not sure until we check. This number right here is a very, very large number when we compare it to the number we have written in here in our scientific notation. So this being positive will make this value large again. So when you're multiplying by 10 to a positive number, it's going to expand this number and make it larger. If you have 10 to the negative, that's a small number, because remember, this would be like 1 over 10 to the fourth, which is 1 over 100,000. So that's a very small number to be multiplied, which is going to make that answer very small. Okay, so keep those things in mind when you are doing scientific notation. Here we are going to multiply these two numbers that are written in scientific notation, and we need to write our answer in scientific notation. So when we look at this, if we really think about this, this is 1.062 times 10 to the 24 times 8.61 times 10 to the 19. All multiplication here. Guess what? Multiplication is, you can do commutative property. So basically what I'm going to do is I'm going to group my decimal values and multiply these times each other. And then I'm going to group my tens with the exponents, and I will multiply these together. So when I do that, 1.062 times 8.61 is 9.14381. 9.14381. When I multiply these together, remember our rules of exponents, we're taking 24 plus the 19, and 24 plus 19 is 10 to the 43rd, and we're going to put our multiplication symbol in there for scientific notation, and our answer is 9.14381 times 10 to the 43rd. And now let's look at this example where we have to divide. Okay, I am going to, again, think about my decimal values, and I'm going to multiply these together, or I'm not multiply, divide them. And when I divide these, I get 0.7014. when I do the division for the scientific notation, that is going to be, I will get 10 to the negative 6 minus the 4, which is 10 to the negative 10. So I get 0.7014 times 10 to the negative 10. This looks like scientific notation, but it's not really totally in the correct format because right now that decimal is not in the right spot. That decimal has to be after the first non-zero digit. Right now it is after a 0. So I need to move that decimal over 1 unit and make this 7.014. Okay. Now I have to think about how my original value of 0.7014 is actually smaller than what I'm going to write of 7.014. So I need to accommodate for that because the actual value is smaller. So I need to make this smaller or bigger, nope, smaller, to be negative 11. So right now, this is the bigger number. I need to make that smaller to accommodate for that change. Okay, because that negative 1 is going to make that smaller by 1 place value, which would then bring that over to get back to where we had it before. Okay, hopefully that makes sense. If not, just make sure you ask in class. So we get 7.014 times 10 to the negative 11. And that's it for day 2.